Good evening and welcome to the session number 21 from the playlist of electrostatic potential and capacitance. The topic is the derivation of electric potential at a point due to a very long uniformly charged wire. So here this is a wire and this wire is uniformly charged and it has a linear charge density. It has got a linear charge density equal to lambda. So we have to find the potential at the point B if the potential at the point A is known to us. So in order to derive the equation, we will first of all go through the formula for the intensity of electric field at a radial distance say r from a uniformly charged very long wire, which is given by lambda divided by 2 pi epsilon naught r, where r is the radial distance of that point from the this uniformly charged infinite wire, and lambda is the linear charge density, and the potential difference, that is delta V, that is VB minus VA, is also given by the line integral of E dot dr. So in this case I have taken 2 points here, and we will be finding the potential at the point B if the potential at the point A is known to us. Now this point A is situated at a radial distance of RA, and the point B is situated at a radial distance of RB from this wire. So from here this VB minus VA will be equal to minus E minus line integral of E is equal to lambda divided by 2 pi epsilon naught r dr, and the limits of integration will be from RA to RB. So from this equation, VB minus VA will be equal to, now here lambda is a constant, 2 pi epsilon naught is also a constant, so minus lambda 2 pi epsilon naught, and we will be getting here integration of 1 upon r dr within the limits of RA and RB. So this is the equation which I have got, and from this equation VB is equal to VA minus lambda upon 2 pi epsilon naught, and here the integration of 1 by r dr, this is the natural logarithm of r within the limits of RA and RB. So from this equation, the potential at the point B will be equal to VA minus lambda divided by 2 pi epsilon naught, and in bracket it will be L, natural logarithm of this is RA. This will be natural logarithm of RB minus natural logarithm of RA, so this will be equal to RB upon RA. So the potential at the point B will be given by this formula, and if we know the potential at the point A, then the potential at the point B can be calculated. So thank you very much for joining this session. In the next session, I will be coming up with a question which will be based on this topic, that is the electric potential due to a very long uniformly charged wire. So till then, have a nice day. Bye.